as somebody who's a non-technical practitioner who's able to use a tool that's meant for software development, where do we draw the line really? What kind of interface would appeal to a non-technical audience as opposed to a technical audience? You take the standard desktop application for ChatGPT or Claude that gives you a text interface which is almost universal. The appeal of a text interface is there whether you just want to have a conversation with the bot and ask it for some specific information. If you're a non-software engineer who is exploring, maybe doing deep research, there's many ways in which different people approach the same interface. People being wary of abstraction if they're domain experts.
Yeah.
Software engineers are less afraid of abstraction.
Absolutely.
I saw a meme the other day that had the big stack where the entire technology world is built on top of multiple layers of abstraction, and there's one Jenga component there that somebody's been thanklessly maintaining in Nebraska.
I remember that, yes.
There's somebody who's put ASML on the bottom because they're the people who help design all the machines for making the chips, and below that somebody has put Excel as one of the blocks. You still need Excel as an underlying component for a lot of teams that are doing extremely hardcore work, because people who are domain experts, they have deep understanding of processes, phenomena, and the limitations of processes. And those things are understood by experimentation.
And the business trade-offs. Another overwhelming thought for this demography of people is that should everybody even be a developer, or should they know how to build code? Because that's antithesis to what is happening.
There is a real possibility that many domain experts will discover the joy of building systems on their own. Vibe coding and generally software systems engineering or development using AI, it lowers the barriers to entry, and there is a separate cadence of its own when you start doing it. And it's very attractive for the reason that there's great gratification you get from building systems that can solve your problems. That kick that you get and the gratification that you get from solving a problem that has been a thorn in your side, that could really inspire a whole generation of people.
Absolutely, yeah.
The future is not arriving in headlines. It is being engineered across industries. Aerospace is evolving. Defense is modernizing. Industries are becoming autonomous. Clean tech is becoming scalable. Semiconductors are powering a new computational era. And beneath it all, a new layer of intelligence is quietly transforming how systems think, decide, and adapt. At Tetris Innovations, we don't just talk about technology in isolation. We explore how disciplines converge, how software meets hardware, how policy meets capital, and how intelligence becomes infrastructure. This channel brings together subject matter experts, policymakers, investors, founders, and industry leaders who are shaping the next industrial chapter. We go beyond buzzwords, beyond hype cycles, beyond surface level analysis. We examine what is scalable, what is defensible, what is deployable at national and global scale. From deep dive podcasts to sharp fireside conversations to hands-on sessions and technical breakdowns. If you're building, investing, governing, or engineering the future, this is your forum. This is Tetris Innovations, where industries evolve and intelligence connects them. If you've landed here directly, watch our 1-minute introduction first, because this isn't just a podcast, it's a front row view of how industries are being rebuilt. And Season 1 begins with the defining shift of this decade: AI, Gen AI, agentic systems. Not hype, infrastructure. Software is no longer just written, it's orchestrated, built with intelligence embedded. So we ask, are agentic systems rewriting engineering? Can leaders build without code? What happens when AI becomes your teammate? To start this journey, I couldn't think of anyone better. From core engineering to a decade deep in AI and data science, he understands machines and models. Rajesh, welcome to Season 1.
Welcome again for the episode 2 In the previous episode, we spoke about the agenticai world, its applicability to engineering as a discipline. Let's now shift our focus to the non-engineering folks. I'm talking of non-software engineering folks. We did make a mention of them being benefactors. The reason I chose to use the word benefactors is because they're also going to be the biggest beneficiaries with the AI revolution. So just to get that conversation going, how does the again the mental model look like for a domain expert in comparison to a software engineer?
Thank you, Ulas, for inviting me to the second episode of the podcast. We talked about software engineering professionals primarily in the first one, right? So to draw a distinction between software engineering professionals and professionals who are not software engineers, who are domain experts in their area, right? I would say that software engineers are trying to build abstractions based on knowledge that they are gathering from a domain. So there's a set of requirements that they get where the abstractions sort of arise from those requirements, and then they build that into a software system which follows a set of rules, a set of checks, verifiability, the patterns. It could be sort of an end-to-end test of some kind. And then finally, there's the operationalization aspect of it, where the application gets deployed and all of the hooks and everything that you need are part of that, right? So that's what a software engineer does.
Sure.
When you look at a domain expert, let's take somebody who's a process engineer in a chemical plant, or a manufacturing engineer who's designing processes for a manufacturing component. Or let's take somebody who's writing a script for a movie. Let's take somebody who is writing a book, right? So all of these are areas where, the individual in question has presumably a lot of domain knowledge already, right? They have a lot of domain knowledge, and you could represent it computationally as entities, relationships between the entities, right?
Sure.
And when you look at it from this perspective, the role of a domain expert is a little different from a role of a software engineer. A domain expert is going to be focused on solving specific problems based on knowledge of phenomena, knowledge of processes and their limitations,
right,
and a deep practical understanding of how things work in reality, as opposed to in a mathematical model or a computational model.
Sure.
Right? So take the example of computer engineering, CAE, or the specific subfield of it could be FEA or it could be CFD. FEA is finite element analysis, and CFD is computational fluid dynamics. These are areas which are associated with structural engineering and structural dynamics analysis of systems. And CFD is associated with computational fluid dynamics, which has to do with the modeling of fluid flows over objects.
Right.
As you can imagine, these are important for everything from pumps and small fluid flow machinery all the way to aircraft and spacecraft and what have you.
Sure.
It could be relevant to cars, it could be relevant to ships and a number of other things, right? So these are situations where a domain expert, the role that they perform is one of building starting from an understanding of phenomena, an understanding of principles, using empirical rules that are established in literature, and then using their experimental knowledge, using their knowledge of systems and how they're built, interfaces of those systems to synthesize an overall application, synthesize an application based on that. So in a sense, both are system builders. Software engineers are also system builders, and domain experts can also be system builders in more or less of a sense, right? So if you're building a book, it's not necessarily a system, it's a product or an output that you're getting. If you're writing a script for a podcast, you're creating a narrative and you're engaging with the ideas that are going to be discussed there, and so on and so forth. If you're building a video as a creator, then you're starting with a hypothesis or an idea and then exploring that in video form. Similarly with, say, somebody who wants to shoot a movie or whatever, right? So in all these different areas, domain experts perform different kinds of roles, right? So is that distinction?
Even if you look at it from a very domain expertise, there are probably two distinctions. One, who are absolutely technical but in a different field, for example, mechanical engineering. And there's another section which is, probably these are people who are functional managers, who are business leaders,
exactly,
who understand their processes well, not as essentially something that is technology, per se. So just taking the comment that you're making, I think one commonality is that the non-software engineers are not wary of technology. They are probably wary of the abstractions. I'll give a classic example for my own self, right? So I've been dabbling with the agentic world for the last 1.5 years, 2 years now. So I understood the concept of an agent. Then now I know what an MCP is. But if I did not have a tool like a cursor, right? It would be very overwhelming for me to set up an MCP server. Setting up an MCP server using a cursor took me a flat 30 minutes. I didn't have to worry about whether my Python was set up correctly, whether the system variables were correct. So a lot of these things are like not my problem anymore. I know very well what an agent can do, and why did I even set it up? I wanted a very simple agent. I give my system a document. In this case, it is a PDF, which is a CV, and I wanted extraction of data from the thing. So it's a single agent system. But for me to get past, setting up all of the things that are essentials was not the problem. Maybe if I did not have a tool like a cursor, I would have been overrun. I would have not even tried. I think that will probably be the view of many of the business and business leaders. I'm calling it, or functional managers.
Yeah, that's a good segue into how AI affects these domain expert roles.
Yeah.
You brought out a great example as somebody who's a non-technical practitioner who's able to use a tool that's meant for software development, right? Where do we draw the line really? What kind of interface would appeal to a non-technical audience as opposed to a technical audience? You take the standard desktop application for ChatGPT or Claude that gives you a text interface which is almost universal. I mean, the appeal of a text interface is there whether you just want to have a conversation with the bot and ask it for some specific information,
right?
Or if you're a software engineer who wants to ask a question and write code with it, or if you're a non-software engineer who is exploring, maybe doing deep research on minerals and metals, and you want to understand stock prices as a financial expert who want to invest in something. So there's many ways in which different people approach the same interface.
Right.
So I think so in addition to what you said about people being wary of abstraction if they're domain experts, I think it's a good distinction to make. Software engineers are less afraid of abstraction.
Absolutely.
Because they're used to it.
Right.
Somebody who's a software engineer, it's about where you're not a fish out of the water, right? It's about in a way of putting it, what is your technical debt?
Right.
As somebody who's learned something, right? So that's one way to put it, I suppose. But you're right that certain user experiences and certain user interfaces cut across and are useful to a range of domain experts as opposed to a specific code-heavy centric or a code-centric workflow like Cursor you described. You probably have used Cursor not only because you've heard the buzz, but you probably dabbled a little bit in development, right?
Right.
Not everybody approaches technology even from that level.
Yeah.
A lot of people might, maybe somebody is a trader on Wall Street or on Dalal Street, and they want to find the best stocks to buy. How do they build a more diverse portfolio, for example? How do they reduce risk or increase rewards or returns? Those may be the considerations, right? And somebody else might be trying to build a very good YouTube channel. They may be trying to build a following for themselves. So they may be looking at advice on SEO and how do I package my video and how do I put the right. So there may be different kinds of conversations here.
Right. Again, another anecdote. Prateek, one of my colleagues. So it was a mental barrier for him to set up, one, sort of an agent and then do something with it. Day for yesterday, I just come in and then he's like jumping in joy, just because he got over that mental barrier to say, I vibe coded and I was able to get an outcome. So now that barrier is like broken. He's a lot more excited to make a functionality work. So you look at that as one point in case.
Yeah.
He's able to actually get over these barriers and then finally get to a point where he's probably having a working system. So what the advancement on the other side, all the other tools that are there. What it is helping business managers is to actually go and build a case. Now, that may not be an MVP, but at least it is a POC that they can, take.
Yeah, and it doesn't always have to be a product.
Right.
It can be a specific component of a workflow. It could be a
Sure.
repeatable workflow with OpenAI or Claude or whatever AI of your choice that you execute every time you need to do something. That is still automation. That is still progress.
Right.
Right. So if you're, let's say every month or every couple of weeks, you've got to run an analysis of your stock portfolio, or every 3 or 4 months, you have to decide to pivot your YouTube channel in a different direction. Or I have this big design spreadsheet that I use as a mechanical engineer for building a certain component. It parameterizes everything and it puts thousands of variables in place and gives me a complex parts specifications.
Nice.
Now, if I have to tweak that without breaking anything, and I want to do that using automation, right? All of these are great use cases for a domain expert who's not a technical person. Remember, this is not, this is a person who's built an Excel sheet or an Excel spreadsheet to size a component. And this is something which is extremely common, by the way. In mechanical engineering teams, there's a lot of people who rely on spreadsheets. I saw a meme the other day that had, the big stack where the entire technology world is built on top of multiple layers of abstraction, and there's one Jenga component there that somebody's been thanklessly maintaining in Nebraska, or something like that. So that meme,
I remember that. Yes.
So there's somebody who's put ASML on the bottom because they're the people who help design all the machines for make the chips. And below that, somebody has put Excel as one of the blocks, right? So you still need Excel as an underlying component for a lot of teams that are doing extremely hardcore work. Because remember what I said in the beginning, right? People who are domain experts, they have deep understanding of processes, phenomena, and the limitations of processes. And those things are understood by experimentation.
And the business trade-offs.
They understand all that through experimentation and through the school of hard knocks, as it were.
Right.
These are not things that are written in textbooks.
Right.
Well, in some cases they may be, but if you go see a ride and handling manual at a big company like Ford, or a place like Caterpillar, where they have reams and reams of books on just this kind of stuff, right? What is the right incline angle? What is the entry and exit angle that you've got to build for your truck?
Right.
Because when you put that thing in a mine, right, you don't want it to be, running into all kinds of obstacles or not being able to cross basic 101 kind of tests.
Right.
So where I'm going with this is any automation that is powered by AI, in my view, is good automation, as long as it adds value to the user, and that it does not have to take the manifestation of a full software application.
Right.
I guess that's the point I'm trying to make. To this end, tools like, we've talked about MCP in the past, tools like MCP might be helpful. Skills, which is a new area within Cloud Code where you can write different skills and you can optimize the agent in specific ways for different tasks. That is useful. There are different tools within the Cloud universe, within the OpenAI universe. There's one markdown file, basically a plain text file called agents.md in the OpenAI world, and there's a similar Claude.md in the Cloud world. Those are also useful, and they can help tune the behaviors of your app, of your agent, to meet your use cases. And this is important because as a domain expert, I don't want it to be doing something that I'm not comfortable with or that I didn't ask it for.
Sure.
And the way in which you can constrain a model to do those kinds of things is by using these kinds of rule sets. So you mentioned cursor earlier, right?
Right.
There's a whole set of tools called cursor rules that allow you to tweak and tune the way cursor works to your specific liking, right?
No, as I say, it is not about the tools, right? Tools are not the barrier.
Tools are not the barrier,
right? It's more so. But now, even execution is cheap, but I think it goes back to what you referenced in the previous episode, which is like, what's the taste? What are you even using it for?
What are you using it for?
I remember you chiding me, saying that, okay, you have a pretty powerful laptop, but what are you actually doing with it?
What are you using? Yeah. Well, it's not so much chiding as a realization, even on my part. No, I'll be honest with you, right? How often do we use the full computational power of our machines?
Absolutely. Yes.
We don't. And it's there's been this whole bunch of hype about why people should buy Mac Minis and put CloudBot on them. The last few days, Twitter has been abuzz with this kind of thing. The truth is that a lot of people don't use the computational power that's available on their laptop.
Right.
And with AI tools, there's a possibility that you might use that
Absolutely.
for furthering your own specific work stream.
That's the bit, right? If you probably asked me, let's say 3-4 years back, the same question, saying, hey, you have a powerful machine, what would you do? I probably would not have had an answer. But now I can tell you that I'm using the whole MCP setup with a milestone to say that I'm not going to go to my team with user stories written in English. So the goal that I have is that I go with a POC that is there in my mind, and that is doable. I can go to them and say, look, this is what I mean, and I think those are the kind of dimensions that the world is taking at this point in time.
That's totally true. I think the fidelity with which you can build even early prototypes is increasing. The fidelity with which you can reason about ideas is going up.
Yeah.
And I think that this is happening more on the small prototype to medium-sized application landscape, that part of the landscape, rather than the big application. And we talked about the big application.
Correct.
And how refactors on them can be notoriously hard, even for agents which are long-running, even for agents which are well-specified, even for LLMs which are powerful. We talked about it in the previous episode.
Right.
Having said that, I think it's in the early prototype to mid-level complexity application that LLM-based engineering is going to excel. Coming back to the topic of domain experts, that's also the space where they will get the most bang for the buck.
Yeah.
Right. With a $20 ChatGPT Plus subscription, or even a ChatGPT Go subscription, which is even less expensive than that, you can get a lot of value for just the tasks that you want to automate.
Absolutely.
On your own machine.
And if you look at high knowledge domains per se, you spoke of engineering. How's that world kind of changing? You've been very close to the manufacturing engineering segment, automotive as well. What kind of disruptions do you see in that space?
I think the current state of the art is something that I might be a little behind on, given that my last core manufacturing experience was almost a decade ago. Just looking at how things have progressed from there, based on what I understood from the public domain, there's a lot of digitalization in general. Manufacturing has always been where you had one foot in the physical world and one foot in the digital world. At least the time that I worked in that space for about 10-12 years, that was the paradigm of the time. What you see now is an increased push towards digitalization and completely digital mock-ups for a lot of components, assemblies and parts, to the point that the models that you see on applications, when I say models, I mean the kinematic models or the structural models that you see in that landscape of mechanical engineering. They are extremely sophisticated now, not just in terms of the modeling approach, but also the load cases, the processes for how to do this, the depth into which many of these go to evaluate failure modes and to avoid failure modes. There's been a lot of progress, I think, in those areas across the board. And, there's this, recently I came across a very interesting take on how the shapes of things that we hold in our hands change over time. And that's because of specific computational capabilities. And this is another computational capability with AI, and that's why I wanted to allude to this. In the early 90s, if you bought a cellular phone, it's likely to have been a very blocky looking rectangular thing with, probably be about that thick, and like a wireless phone with a speaker and a headpiece at this end and a speaker at that end and an antenna sticking out of the side, right? Now, the moment NURBS splines, these are non-uniform rational B-splines, the moment these got introduced into computational geometry, and this happened probably for the first time with the design of the B-2 bomber in the 1980s with CATIA V4. And these were running on extremely ancient PCs. And they became mainstream probably in the late 90s. So you started seeing very complex geometries that started being churned out by design labs. So Sony Ericsson phones were very famous for this, right? So they had very cool shapes for the surfaces and the buttons and everything. And you had Nokia, the 6600 and those kinds of very cool looking phones. They came out at the time. Looking back, that was a Cambrian explosion of shapes. at that point in time, which does not exist now. Everything is a rectangle or a brick right now, unfortunately. But to extend that idea to AI, right? The potential that you have for building new things with AI is extreme. I mean, it's lowered the barriers to entry, and it's lowered the barriers to innovation for a lot of teams. I think that there's going to be a lot of experimentation, not just in terms of the design, but also the systems and processes, in terms of complex geometries that we can imagine for things. Topology optimization comes to mind, which is an application of AI in the space of shape design. Right? There's a number of areas where traditional empirical formulas that we trusted because they were written in a book can now be experimented upon, and we can set up new experiments and learn from them and build newer applications.
How do you see researchers? That's another category of people who are not essentially acquainted to software engineering, but they're deeply technical.
Absolutely, that's a great question. I think researchers represent a breed of functional experts or domain experts who may not be, let's leave aside the researchers in computer science for a second. Let's look at, or AI for that matter, because we know that they are required to have the necessary underpinnings, right?
Sure.
Let's look at a researcher in something like soil mechanics or something like astronomy, right? They're going to look at physical phenomena,
or radiologists.
Yeah. They're going to look at physical phenomena or real world processes, right? For them, I think the way in which domain expertise and AI are going to meet is a little different. As I said earlier, there may be specific parts of their workflow that could be made easier. If I was detecting a tumor after painstaking examination of an X-ray or a CT scan, now I can have an AI take a first shot at determining where the potential malignancies could be, and then narrow down to a few.
But how easy has it become for them to use? You could prompt and probably get a geometric shape out of a cavity or something like that. Right?
Exactly. Yeah.
But if you draw these two examples, is the space for automation in the engineering space as well formed as it is for, let's say, software engineering space?
Yeah. I want to go back to one of the ideas that we discussed in the last podcast, and that is context engineering. Context engineering is all about how do we prepare the field so that agents can work on a problem. As a software engineer, when you're dealing with data or code, you can allow that data or code to be appropriately available as context in the LLM's context history, so that the agent can reference that context and prepare the appropriate output. Now, what a real-world application like an X-ray analysis or a design analysis or maybe a geophysical analysis, what those are missing is all of this rich context around the existing data that's been collected from that domain, the sort of different models that are there, mathematical models that may be applicable for, say, machining a part or for analyzing soil mechanics or analyzing geophysical, maybe a rock in the context of petroleum, or analyzing a network in the context of telecom, right? Or it could be any of those things. That context is not available to the agent.
Sure.
That's the big distinction now that prevents agents from being as effective as in software engineering.
This is more about how much of domain knowledge can you feed into the LLM?
Yes, how much of domain knowledge can you feed into the LLM? I would be at a loss if I said that next token prediction is all you need. I would be at a loss if I said that the current paradigm of LLMs is all there needs to be, because that does not bring us closer to an even higher level of artificial intelligence, right? But what I can say is that within the context window that's available to us with these LLMs, if we can provide additional relevant information that can make the agents more efficient and better, whichever the domain.
Right.
I mean, in the domain of software engineering, that is in the form of code and data.
Right.
In the domain of radiology, it could be something else. In the domain of mechanical engineering, it could be something else, right? It could be components and the general patterns, that we see across different components and so on and so forth. Yeah.
That's a little bit of a deeper of a conversation.
Yes,
right?
it is. Yeah.
I think we probably will take it into another
We can,
section.
yeah, we can.
In this
Yeah.
the same episode, but a little later in the thing. Just trying to conclude on this bit, right? If you were to look at how other functional managers,
Yeah.
I started off saying that they are the beneficiaries. My general view is that they haven't still seen the full benefit of what they get out of such kind of systems. Some maybe because we're not building systems for them. Second bit is maybe they are not acquainted, or I don't know if they have the mindset to go and then start using systems of that sort. Any views on that?
Yeah, I do have a view on that. For a long time in different industries, we've had what are called visual management systems. The visual management system is where you have some visual representation of the key metrics of your business that are displayed for functional managers and strategic managers to look at on a daily basis.
Right.
When you do a stand-up in the modern software environment, people could, for all intents and purposes, be sitting down. I'm saying that tongue-in-cheek because a stand-up call, as I've seen it in manufacturing enterprises, is where literally people are standing around and looking at various dashboards and displays that tell us what the state of different components is, how much stock do I have, how much inventory do I have, what is my first pass yield or defects per thousand for a certain part of the production line, etc., etc., etc. You can extend the same idea of a manufacturing visual management system to any other domain.
Sure.
You can have a Kanban for yourself as a content creator or a podcaster saying, I have this particular thing in the works, I have published this yesterday, and I'm going to be publishing this tomorrow, and so on and so forth. So you can visualize your pipeline. Right. Salespeople do it all the time. They have something called a sales funnel, right? That allows them to look at what prospects are there, who are we evaluating right now, and who are the converted customers who are going to buy our product. So in this fashion, you can see that there's a lot of data that's being collected about any business or its functions by very nature of the business existing.
Right.
And it's only a step from there to start integrating AI into different workflows.
Sure.
Right. So I feel like whichever these components are, whatever the nuts and bolts you're talking about with respect to a certain domain or a certain sub-process or a certain functional area or a certain other one, there's a way in which you can use the current state of AI and bring it to bear on those metrics, on those processes, on those systems.
Another overwhelming thought for this demography of people is that should I become a developer? The way I'm looking at it is that you probably should ask the question from the other side. Should everybody even be a developer, or should they know how to build code? Because that's antithesis to what is happening. Right?
Yeah, it is an antithesis.
Yeah. So you want to pick that thread? I know it is.
No, this is really interesting for one or two reasons. You can have talent go in either direction. You can have software developers who are used to doing 10x software engineering realize that my profession has become commoditized and go in the direction of becoming a domain expert in a certain area.
Right.
So that's the counterpoint to what you said.
Yeah.
Having said that, there is a real possibility that many domain experts will discover the joy of building systems on their own. Right? There is a joy to this. Vibe coding and generally software systems engineering or development using AI, it lowers the barriers to entry, and there is a separate cadence of its own when you start doing it. And it's very attractive for the reason that there's great gratification you get from building systems that can solve your problems.
Sure.
That kick that you get and that gratification that you get from solving a problem that has been a thorn in your side, for example, that could really inspire a whole generation of people.
Absolutely.
It could inspire, if not a whole generation, at least a number of people who really think that they should be doing this for more problem statements. So I was speaking to one of our mutual friends, Madhav, in the context of petrochemical engineering, and he was telling me about heuristics, a very well-known set of empirical formulae that are held dear and secret, you could say.
Right.
Of course, he didn't tell me any details of that, neither was I interested, but the thing I took away from that was that there are many processes out there. There are that are hidden, or I should say, whose purpose is very, very specific and which are not publicized and which actually have an outsized impact on the world's economy. So if you were to look at an oil well and predict its lifetime value,
Right.
and if you have an empirical way of doing that, you can tell that is going to impact everything from that company's fortunes to the broader economy as a whole. Right. I mean, everybody is going to be coming back and looking at what is the empirical formula that they understood, that they experimented upon, and that they have, which can be used to forecast well lifetimes, and how is that useful. So it's those kinds of scenarios that you can really build with AI. I mean, as a domain expert, if you know exactly what's going on there, you can really synthesize an application which can automate the bulk of your work.
So, any tools that you have come across, it may not be the entire expanse. We could always, come up with a list at a later point if there's interest from our viewers. But if you were to look at some of those tools which are really enabling, maybe even the 50% of the demographic people that we spoke of, any suggestions that you want to make?
So you're talking about tools which are built by,
which are enabling
domain experts. Enabling domain experts. I can't name specific names, but there is one sub area that I'd like to talk about.
Okay.
There is, for a long time, 3D CAD has been the cornerstone of a lot of mechanical engineering shops.
Sure.
And I'm saying this I'm saying this as somebody who's seen 3D CAD evolve over about 20 years. What's happening is the CAD that was there 20 years ago is not the same CAD that you have today, both in terms of the richness of the feature set and also in the recent past, how AI is helping transform that world, right? So now, even as recently as a couple of months ago, there were startups working on the text to geometry problem statements, where if I wanted to build a component, I would prompt it. Because this is the era of prompting.
Absolutely, yeah.
Claude or OpenAI or whatever to do whatever you want. So why not just prompt a part, right? So that's a powerful idea when you think about it. If I can prompt a video like Sora, if I can prompt a piece of text, can I not prompt a point cloud?
Yeah.
Because a point cloud is another form of data, just like text tokens are a form of data. So that's where we are going, I think, with CAD, where and I will not say that it's fail-proof, because I can easily imagine a number of ways in which prompting a part can go wrong for you. But it is certainly one frontier. Democratization of geometry, the democratization of manufacturing kind of happened through 3D printing. Right. So 3D printing was a revolution that happened a few years ago. It's gone so mainstream that people use it, and we don't even know that something is 3D printed. It's one of those successful trends that has disappeared into the mainstream. It's really part of everything around us these days. So we might even come across a future application where you can just prompt a geometry and then have it 3D printed for you. It's probably already happening. As they say, the future is already here, but unevenly distributed. Right.
It's more like, I wanted to bring this point earlier. It's more like how SaaS is just becoming an infrastructure at the back. Nobody will realize that, right? Everything is just going to be an intent-based interface. And while you were talking about CAD, the media team here was talking about a tool that they probably use now. This is where we're getting to, right? It's kind of enabling class of people, how their trade is changing. I think it's very interesting.
Exactly. And sometime back there was a lot of buzz around the metaverse and the fact that 3D and virtual reality could be democratized, just as say 3D printing was democratized in an earlier revolution. I don't know if that's really taken off. That would be an interesting sub-problem statement, because virtual worlds and 3D have been neck and neck. Virtual worlds and 3D have been influenced by the need to build computer simulations of objects, and that ranges from building parts for a car or an airplane, all the way to building some form of game where you experience a virtual world as in a first-person kind of environment. A couple of days ago, Google dropped a model that is able to create what's called a Gaussian splat from just an image. You can literally feed an image to it, and it will generate a 3D world for you, and you can walk around in it. So game stocks fell significantly, as you can imagine, because of the fact that this innovation came through. In a sense, and I've been telling Meera this, I mean, in 2018 or 2019, when I saw generative adversarial networks, I said to Meera that we will see a future in which games are designed by deep learning models. And fast forward to 2026, it's slowly happening. Right. Yeah. So I think I see this kind of confluence of different capabilities for whether it's agentic AI or just the foundational capabilities of LLMs to reason with different kinds of input data and different kinds of output data. We are seeing that entire swath of capabilities emerge across domains.
That's taking the conversation to the other interesting shift that is happening, right? Where you're looking at intuition-based, models that are being worked upon. It's not there yet. Maybe it is there. In a few pieces. We'll come to that section. But just before we go there, I think one question that is there. We talked about vibe coding. We talked about how engineers can do it. How we're looking at business functions can do it. But not everything should be vibe coded. Where do you draw the line? How much of this remains as a POC? In what segments do you want to say, hey, I'll go beyond a POC, go beyond an MVP? I think there has to be a balance around this, right? Not everything can go.
Yeah, it comes down to product vision and taste. Those are two things that I would say. There are certain no-go areas, and we all know that, right? When we are putting an application to production that's vibe coded, it is likely to break for many reasons in the current state of things. And we've talked about some of these capabilities in the last podcast, whether it's the capabilities of foundation models or the way the agents are built, and a bunch of other things like context and so on. I think a practical way in which we can see this is the vision of the product should encompass what has to go to the customer.
Right.
And that vision should be tightly negotiated. So that when we are vibe coding an application, the requirements fall into place, and the associated code and tests and everything that's developed really is on point. Right. There are some areas where I would be a little tentative about putting a product out there that's vibe coded as of today.
Right.
And I think those would be medical, especially where it has to do with diagnoses or surgery or those kinds of areas. For the obvious reason that it could lead to some proportionally higher outcome on the negative side for a patient. Right. Similarly, I would be at a loss to put a vibe coded application in front of any other safety critical infrastructure or any other safety critical applications, such as any of the release systems in a car. Or the systems that allow us to be safe in a car, passive safety, active safety systems in a car.
Right.
I'm pretty sure that other
BFSI is one.
BFSI is another area. Where, so there's
again not all operations.
There's loan risk and there's credit risk and stuff like that.
Again, you have probably segments of what can go in as without too much of a defense is the other. Having said that, we have vibe coded it, but this is vibe coded with a lot of supervision in the defense space. So it does not go out without proper due diligence. So again, just to repeat to everybody here, we are talking of non software engineers vibe coding and pushing things. And it's not the other set. So
exactly.
So interesting. So just taking the discussion a little beyond, right? We just spoke of, how much of domain knowledge can go into the LLM. So I'm just going to the next category of, use cases maybe. So it's open question. What are you seeing in this field?
What I'm seeing is that LLMs, at least in the recent past, have been able to encode a surprising amount of domain knowledge from different domains. They are subject to the same risks that we know LLMs to be prone to. One risk is, of course, hallucination.
Right.
And I mean, the thing is, hallucination, if you understand it really well, is actually a feature, not a bug. Because the way a language model predicts is by next token prediction.
Right.
And the next token gets appended to the context, and you predict the next token after that, and so on and so forth. With the result that you have quadratic error progression, right? This is a known fact. But the specific thing that I want to allude to in the context of knowledge is, even if you have prior knowledge to start with, the reasoning that leads to subsequent outputs from the LLM may not be on point. So there could be patches of knowledge that the LLM gets right, and subsequent portions of what it generates after that patch of knowledge that it has generated upon the initial context that we provided to it, or the input prompt that we provided to it, that could be off course, right? So LLMs come with certain issues which are sort of foundational or structural in nature by the very design of the current transformer architecture. Right. So there are alternative directions for the development of AI that are currently emerging. Jan LeCun has been in the news of late, and his work centers on joint embedding prediction architecture, or JEPA. Right. So this is an alternative to the current paradigm of transformer LLMs.
Right.
There's also other models like diffusion text models. And these are also another category of models that use a different architecture, where you progressively remove noise from a text field of noise, so that you arrive at the output that you desire, right? And machine learning at its core is about the minimization of loss from some data that you've generated, so that you can arrive at better and better predictions, right? I mean, if you look back at different paradigms, whether it's discriminative learning or it's generative learning, there are loss functions involved.
Right.
I think to answer your question about how much knowledge machine learning models encode, when you're feeding internet scale text data into an LLM and asking it to go through these repeated iterative cycles of training, there is certainly going to be a lot of that knowledge which will be encoded as by very nature of the training process. Because the next token in a well-defined knowledge set, if you take all that together, it's going to encode some aspect of the domain that you're.
That's the next frontier, right? Trying to have models which with having an intuition, being able to discover new things. These are all probably where the world is essentially going. And I remember you mentioning AlphaFold as a case. So AlphaFold, I think, is a specific application of graph neural networks in the context of protein folding. When you look at proteins, you can visualize them as graphs. Although I have not done direct work in this space on protein folding, I have done a lot of graph neural networks related stuff, and the intuition is straightforward. If you can represent a protein as a graph, you can find alternative variations of that you can learn using a graph neural network. And graph neural networks are not so the interesting thing is, graph neural networks are not the paradigm that is currently sought after. And there's a disincentive in the broader AI landscape to explore ideas that buck the current trend. It's just by virtue of what people have invested in the current state. I think there's a number of labs that are looking at frontier models that use other kinds of predictive architectures. Right? Some of them are basing their work on top of category theory. Which is a certain area of mathematics that provides the scaffolding for all kinds of other mathematics to unfold, right? I think there is certainly a direction there, which can become a sustainable future research area for anybody building the next architectures for AI. Oh, absolutely. I think this world is just emerging, and like how you mentioned, what would probably be the reality the previous week would not be the same. So There are a lot more topics that we would want to cover over a period of time, both directly relating to how this space is emerging, and also on the application side where we are relating it to what's happening in each of the industries. Those are subsequent episodes that we will get into. Rajesh, it's been wonderful speaking with you. We will certainly have you back on some of the other episodes for sure, and one of them will certainly be around what you're doing on Praval. Yeah. Any advice for people who are into the space? Either they are, you could refer it to both engineers as well as non-engineers.
Yeah, thank you so much for having me on this couple of podcasts. And I think the field is very exciting. It's intense. The scale of innovation, the pace of innovation can take people by shock sometimes.
Yeah.
There's a lot that's changing both for domain experts and for software engineers in terms of the ground realities of what they can do with AI. And I think in terms of attitudinal position, if you're an explorer who does not mind engaging with the current state of the art, who's unafraid of stepping out of their comfort zone to look at what these new tools provide, I believe that's a good situation to be in, because that can arm you with the right kind of spirit to take up these applications, to take up these AI models, and really go to the next level in terms of, number one, your own productivity. But also, number two, innovating new things in your domain. And this applies to domain experts, but it also equally applies to software engineers.
Right.
There are areas of knowledge which you thought you would not touch in your career. A Rust engineer in 2016 may not have thought that they would want to write something other than Rust. A Python engineer in 2013 may not have thought that they would want to experiment with any other language.
Right.
But I think those realities are changing.
Right.
I'm not talking only, I gave the example of a couple of languages, but it's not limited to languages. It could be any technology.
Right.
I also feel like the field is lending itself very well to disruptors. There's a lot of progress that you see on a daily basis where people are building meta frameworks, plugins for Claude, plugins for Cursor, and so on and so forth. So for those builders who are interested in contributing to the revolution, but by not building foundational capabilities, it's a beautiful time to be exploring right now.
Absolutely.
Right. So I think what you said in the earlier podcast and in the current podcast about domain experts and about software engineers and how they sort of need to have a higher risk appetite. I think those are extremely important things to keep in mind going forward.
Thanks again. As we promised, we will get a lot more hands-on as we move further. So stay tuned. Vibe coding or otherwise, I think keep the good vibes on. Have a good one, and we'll see you soon. Thanks.